What is up, GCSE maths kids? Tutor Jane here, and today I've decided to go through a maths past paper, specifically the Cambridge International GCSE series. This is paper 2 in particular, from the May-June 2022 series. I'm doing this because it was requested. And yeah, so I'm going to go through this at my own pace. I've decided to release this paper in parts because, let's be real, no one's going to sit down and watch a video for an hour, right? So I'm going to try and make this 10-15 minutes long. So I'm only going to go through a couple of questions, the first couple of pages in this part. Please do let me know if you want me to continue and finish the paper. And I'll release the rest of the paper as separate parts later. So let's crack on. By the way, this is going to be an unedited video. So if I'm going too slowly, please feel free to watch this on 1.5 or 2 times speed. So let's crack on. Question 1, write down a prime number between 30 and 40. So there are only 2 options here, really, 31 and 37. Every other number between 31 and 40 is divisible by 1 itself and something else, whereas a prime number is a number that's only divisible by 1 and itself. Cool. So question 2, calculate 4 to the power of 5 minus 5 to the power of 4. So as this is a calculator paper, I'm just going to punch this into my calculator, but I'm going to show you what I do. So 4 to the power of 5 is 1,024 minus 5 to the power of 4, which is 625. So 1,024 minus 625 is 399. I'm going to try to make my handwriting more legible. Perfect. Question 3. Jason starts a run at 10:05 a.m. and finishes at 1:02 p.m. Work out the time Jason takes to complete the run. So he starts at 10:05 and finishes at 1:02. So if we take 10:05 a.m. and add 3 hours, we're going to get 1:05 p.m. Except he doesn't finish at 1:05, he finishes at 1:02. So we're just going to take away 3 minutes from this, and we're going to get 2 hours and 57 minutes. Perfect. So calculate 1 minus 0.7 divided by 0.45 minus 0.38. So that's 0.07. Yeah, so this is 0.3 divided by 0.07. Again, it's going to go into my calculator. So this is 4.2857 dot dot dot. The question is specifically requesting the answer to 4 significant figures. So we're going to take our 5 and round it up because of our 7 here. So this is going to be 4.2864 significant figures. Cool. Kirsty changes $380.80 into pounds when £1 equals $1.19. Calculate the amount Kirsty receives. So we know that £1 is $1.19, and she has $380.80. So to go from this to this, we're going to multiply by 320. And I know that because I've done 380 divided by $1.19, and to go from 380 to $1.19, you divide by 320. So to go the other way, you multiply by 320. So to go from £1 to whatever it is that she's going to get for $380.80, we're just going to multiply it by 320, and you're going to get £320. Cool. Write 180 as a product of its prime factors. So 180 is 18 times 10. 10 is 5 and 2. These are prime, so I can stop there. 18 is 9 and 2. 2 is a prime. 9 is 3 times 3. So our prime numbers, our prime factors even, are 2 times 2 times 3 times 3 times 5. 2, 2, 3, 3, 5. Perfect. Without using a calculator, work out 3 over 7 minus 2 over 21. You must show all your working out and give your answers as a fraction in its simplest form. So 3 over 7 minus 2 over 21. So to do this, I first need to take this denominator and make it the same as this one here. And I'm going to do that by multiplying it by 3, but because it's a fraction, what happens to the bottom has to happen to the top. So this is going to be 9 upon 21 minus 2 upon 21, which is going to be 7 over 21. And we can divide both sides by 7 to get 1 over 3. So our final answer in its simplest form is the fraction a third. Perfect. Question 8. S equals half of AT squared. Work out the value of S when A equals 0.9 and T equals 4. So you can just put this into your calculator, but S equals half times 0.9 times 4 squared. 4 squared is 16 times by a half is 8. So 8 times 0.9, which is 7.2. I did that in my head, but you can just do it on a calculator too. Rearrange the formula to find T in terms of S and A. So S equals half a T squared. So we're going to get rid of the half by multiplying both sides by 2. So we get 2S equals a T squared. So we're going to get rid of the A by dividing both sides by A. So we're going to get 2S over A equals T squared. And we're going to get rid of the square by doing the opposite, which is square rooting. So T equals the square root of, sorry, this shouldn't be 2A, 2S. T equals the square root of 2S over A. And whenever we square root something, we always, there we go. Whenever we square root something, our answer can either be positive or negative, because when we square a negative number, we get a positive number. So our answer is, strictly speaking, plus or minus square root of 2S over A. Perfect. Factorize completely 14xy minus 7x squared. So to factorize, we're going to take out the highest factor that both terms have in common. So in terms of the numbers, we can take out the 7. And in terms of the letters, we can take out the y. So if we take out 7y from the first term, we're going to get 2x. If we take out 7y from minus 7y squared, we're going to get minus y. And if we expand the brackets, just to double check, we are going to get 14xy minus 7y squared, which is the same as our original question up here. So our answer is 7y into 2x minus y. Perfect. Question 10. Find the next term of the sequence. So here we're going 22 to 17, so that's going to be minus 5. And then 17 to 12, minus 5, 12 to 7, minus 5, etc. So find the next term of the sequence. It's going to be 2 minus 5, which is going to be minus 3. Find the nth term of the sequence. So to work out the nth term, we are going to first find out the common difference, which in this case is minus 5. And then we're going to write an expression for minus 5n. So for our first, second, third, fourth, fifth terms, etc. So the first term of our minus 5n sequence is going to be minus 5, then minus 10, minus 15, minus 20, minus 25. Now I'm going to plug in my original sequence here, which is the first term was 22, second term was 17, then 12, then 7, then 2. And then I'm going to take away my new sequence from my original sequence. So 22 minus 5 is 27. 17 minus 10 is 27. 12 minus 15 is 27. 27, 27, etc. So this is our constant of our nth term sequence. So the formula for the nth term is going to be minus 5n plus 27, or 27 minus 5n, which is the same thing, just rearranged. Perfect. I don't want this to drag on too long, so let's make this our last question. Triangle ABC is mathematically similar to triangle PQR. Calculate QR. So QR is this length here. And these two triangles are mathematically similar, which means that the corresponding angles are equal and the corresponding sides are in the same ratio. So let's work out how we get let's work out how we convert between our big triangle and our small triangle. And by that, I mean, let's work out what the scale factor difference is. So how do we get from 8 to 6? Let's just do 8 divided by 6, which is going to be 4 over 3. So if we divide 8 by 4 over 3, we're going to get 6. Dividing by 4 over 3 is the same as multiplying by 3 over 4. So we can say that we can use a scale factor of 3/4 or 0.75 to convert between our big triangle and our small triangle. So to work out what QR is, which is this length here, we're going to take our corresponding length of the big triangle, which is 6, and we're going to multiply it by the scale factor to get the small side of the smaller triangle, which is 3/4. So that's going to be 18/4, which is going to be 4.5 centimeters. Perfect. The two triangles are the cross sections of two mathematically similar prisms. The volume of the large prism is 320 centimeters cubed. Calculate the volume of the smaller prism. So now to do this, it's important to note that we're dealing with volumes now instead of sides. So our scale factor when converting between our sides, right, between 8 and 6, our scale factor there is 3/4. When we convert between our big triangle and our small triangle, we multiply by 3/4. But now because we're working in 3 dimensions, because we're dealing with a volume of 320 centimeters cubed, because we're dealing with a volume, we're going to cube our scale factor. So instead of multiplying by 3/4, you're going to multiply by 27/64. So we're going to take our volume of our larger prism, which is 320, and we're going to multiply it by our modified scale factor for dealing with volumes, 3/4 cubed. And that's the same as multiplying by 27/64, as pointed out here. But we can just plug that into our calculators. So 320 times 27 divided by 64 gives you 135. So 135 centimeters cubed is the volume of the smaller prism. Anyway, like I said, I think I might call it a day here because I don't want this to drag on too long. There are still several pages left of this past paper. So if you enjoyed this video and you want to see more like this and you want me to finish the rest of this past paper, please do let me know. Please do give this video a thumbs up if you liked it and enjoyed it, and let me know in the comments if you want me to continue going through this past paper in a part 2 and part 3. I just want to know that this is actually helpful to someone before I spend more time on it, you know? Yeah, and additionally, I've been releasing several shorts where I go through some common GCSE maths topics, some easy ones, some difficult ones, all examinable, and I make up my own questions, and at the end of each of my shorts, I leave a question for you guys to answer. So please do give those a go because it's good practice, and let me know what the answers are to my questions in the comments of those shorts. And if you don't understand one of those topics, let me know and I can make a longer video explaining more about the topic, like I did with the quadratics introduction video that I made. But yeah, anyway, that is all for this video. If you liked it, enjoyed it, please do hit that thumbs up button. Please do share it with anyone who you think may find it useful. And also hit that subscribe button if you haven't subscribed already. And I will see you next time. Bye for now.